These are non-contact voltage testers. A lot of electricians own one. They're extremely useful, but they're also misunderstood. And that misunderstanding can get people hurt. In this video, we're gonna take a look at what these do well and where we need to be careful. Hey, my name is Dustin. I'm a licensed master electrician. Welcome to this episode of Smarter Sparky. For those that might not be familiar with these, they don't actually measure voltage. They detect the presence of an electric field created by energized conductors. That might sound like a technicality, but it is critical for understanding their limitations. Now, this functionality is actually really useful because it can tell you if a circuit is on or not without actually needing to touch the circuit. Now, these things have a lot of different names. I call them a tick tester, and that's what I'm going to be calling them the rest of this video. Here's an extension cord that's plugged in, and if we hold the tester up close to the cord, it lights up and beeps, indicating that the cord is plugged in. Now, if I unplug the extension cord, the indicator no longer shows that it's energized. Now, it works also on NM and Romex cables to see if they are live or dead. Because the insulation is thin, the electric field is easy for the tester to detect. Some models can also get poked into the hot terminal of a receptacle to indicate if the receptacle is on or not. A quick note, these testers only work on AC voltage, like household circuits. They won't detect DC circuits like batteries or solar panels. Also, they don't work on shielded or armored cables. So these testers are pretty cool, but they do have some drawbacks. Take this box fan, for example. Now, I can turn this on and off, so we know the cord is live. But if I hold the tester up to the cable, it shows that the cord is dead. Now, why does that happen? Because I'm actually on the wrong side of the cord. I've got the tester held up against the neutral wire. So the tester is unable to see the electromagnetic field around the wire. If I move the tester to the other side of the cord, it does show that an electric field is present and indicates the cord is live. This same caveat applies to NM, aka Romex cables. If you hold the tester in the wrong location, it will show a false negative. And in a live receptacle, if you poke the tester into the neutral side, it will show that the circuit is off. These testers only work when they are in very close proximity to the live or hot conductor. These testers will also give false positives. Here I have a roll of 12-3NM, aka Romex. And in this rough demonstration, I have the black, the white, and the ground connected to the source. In this case, just a plug-in cable. On the other end, I have temporarily connected to a receptacle, and I have this lamp plugged into that receptacle. As you can see, I've got the lamp on. I can turn the lamp on and off. Notice I left the red wire disconnected on both ends. If I test the black wire with the tester, it makes sense that it indicates the conductor is live, but check this out. If I test the red conductor, it also shows that it's live, but we can clearly see it's disconnected on both ends. The reason for this is capacitive coupling, which that does get a little deep into electrical theory. Basically, the energized conductor in this coil is inducing voltage into this unused wire. In other words, this is ghost voltage. And while we can detect it, it can't actually deliver usable power. We could not connect a load to this red wire and draw power from it. Ghost voltage can be induced in wires within conduits as well, because the wires are in close proximity to each other. These tick testers are great. I carry one at work all the time. As a matter of fact, this is my preferred model right here. I've got this Milwaukee one here. It seems to be pretty decent, but I've never used this in production. I've always used this Fluke model right here. It's important to remember that these things can and do lie. And because of that, they are not a life safety device. If your life depends on a circuit being de-energized, you need to use a contact style tester or a multimeter. Always verify with a tool that actually measures voltage. They're a close enough kind of tool. If you've made it this far in the video, consider leaving a like and a comment below, and even a subscription if I've earned it. Thanks for watching. See you on the next one. Bye. Here's a little bonus footage for the nerdy ones. I actually connected a multimeter, an actual voltage meter, to the red wire, and I'm measuring voltage to ground here. And you can see we're inducing almost 56 volts into this red wire. Now again, that is not usable voltage. This is ghost voltage. And there actually is a way to get this meter to not read that 56 volts. Just as a teaser, that's actually what that low Z function on your meter does. If you flip to low Z, notice it reads 0 volts now. Now the Fluke 117, it actually combines low Z and auto voltage, so it is auto ranging to DC right now because it is not seeing any AC at all there. So it's a combined function, that's why it says DC there, but it is measuring for that low Z functionality. Low Z stands for low impedance. That is a function I wish to discuss in a future video, but I know somebody's gonna scream that out in the comments. Oh, what about low Z? Yep, that's what that's for, but we're gonna have a whole video on that in the future. All right, thanks for watching, guys. Talk to you later.